Okay, in this video, we are going to look at another modeling periodic functions um, example. So in this question, we're given a description of a situation, and we're asked to graph, and we'll also be asked to come up with the equation. So this is probably the more challenging type of modeling periodic function questions, where you don't have an equation. So we're given a situation, so we have a pedal, or a bicycle pedals rotating. So they're going to rotate in a circle. Okay, so like you have a pedal here, and it's going to be attached to the middle here, and it's going to go around in a circle. The bike is pedaled so that it reaches a maximum height. So the maximum height is 45.5, and the minimum height, so the minimum height here, would be 12.5. So we need to figure out those four key features. We need the amplitude. So the amplitude is always going to be the distance from sort of the middle to the highest or lowest points. If you have the highest and lowest points, the easiest way to get that, and this will also be our A value, is to just take the highest point minus the lowest point and divide them by 2. Because the highest minus the lowest point will give you this distance from the top to the bottom, and if you divide by 2, that will give you what you're looking for. So this would be 16.5. We also want the equation of the axes. So the equation of the axes is going to be whatever the middle height is. And in this case, the middle height, the way to get that if you have the max and min, is to add them up and divide by 2. Which in this case would be 29. So that's the middle number, that's the average of the two. We need the period. So the period, we were told that the bicycle cycles at 20 cycles per minute. So this pedal goes around 20 times in a minute. So the period is just how long does it take for it to go around once. So if there's 60 seconds in a minute, and it pedals at a rate of 20 cycles per minute, that would mean that it goes around 3 times per second. So the period would be 3 seconds, so not per second. 3 seconds. So it takes 3 seconds for it to go around once. Okay, so those 3 things should allow us to graph. So our graph will look like that. We need a scale. So remember, the scale, always take the period and divide it by 4. So in this case, that would be 3 over 4 seconds. So this will be 3 over 4. This would be 6 over 4, 9 over 4, 12 over 4, or 3 seconds. We want to go 4 more. This would be 6 seconds. We don't need the negative area here because the height is always positive. We want to extend this a little higher. We need a scale for our vertical scale. So just make sure you get your maximum value, which is 45, and your minimum value, which is 12.5. I'm going to skip a few numbers to start off with, and so I'll make this 12.5. I will make this 29, and I will make this, so I'm going up by equal amounts, 45.5. So I went up by 16.5, which seems like a weird number to go up by, but basically I'm going up by the amplitudes. So you only need those key points, right? My equation of the axes is right here at 29, and the other two is going to be my max and my min. I think we were told that when we want to graph, assuming the pedal starts at its maximum height. So that tells us sort of the phase shift or where to start. So my starting value is going to be right at the top. I know the period's 3 seconds. So it gets back to its maximum at 3 seconds. In between, it's going to be at its minimum, 12.5. And in between those, it's at the equation of the axis. And then I can just sort of repeat for the next cycle. So the graph would look something like this. Make sure you label the axes. So this was T, this was H for height. So that would be what the graph would look like. You'd likely also want to be able to get the equation, but the equation shouldn't be too hard because we figured out pretty much everything we need to figure out. We know the A value, right? The A value was 16.5. We know the C value, the vertical shift, is 29. The K value, we would have to take the period, 2 pi, and divide by the period. In this case, probably easier to do 2 pi times 1 over the period. Which would be, the period was 3 seconds, so just 2 pi by 3 is fine. So that's our K value. And then the phase shift would depend which type of function we want, sine or cosine. In this case, because it starts at its highest point, probably easiest to just use a cosine function, and then you don't have a phase shift, because a cosine function, if it's starting at its maximum, doesn't have a phase shift. So 16.5 cosine 2 pi by 3 t plus 29, and that would work. If you wanted to do a sine function, say the question asked you to do a sine function, then you just have to have a phase shift to sort of where a sine function, you have to figure out where that sine function normally starts, which is at the equation of the axes, right? That's where it would be transformed from, and not this point at the equation of the axes, because at this point it's going down. It's the point where it goes up from the equation of the axes. So you have to figure out what this point was, which was 9 over 4, right? 3 over 4, 6 over 4. This one's 9 over 4. So if you want to use a sine function, you have same amplitude, sine, same k value, 2 pi by 3. Here we need another bracket, t, and then it would be minus 9 over 4. And then the same c value. So that would be the sine function, so these two equations represent the same graph, the one we have up here.